Okay, so eyes on me, look up. Okay, so today, is the first unit you've had with me as a teacher. I don't like to have things go right up to the test. I feel like the test is so important because it's 80% of your term grade that you need to have a good number of days to really prepare. And it's 2 practice tests. Also the reason why this is the last assigned homework packet. There's no more concepts to go over other than just to help you understand how to apply those concepts to homework and or practice tests. And this is pretty much the pattern whenever I give a test. I try to give a good advance notice and some good time to make sure you're really ready. So today the plan is to talk in class about as many questions from this as you would like. Again, make sure you are focused on the concepts. You're not practicing problems because you do the problems again. You're practicing using the concepts. So don't hesitate to speak up, talk as much as you want. Anyway, we'll talk about the blue packet, get those questions answered. Once that's done, basically I'll just give you time to work on the practice test. So last period we actually spent the whole period questions. It was a good number of things about the blue. But if we have extra time, we'll just give it to work on this. So, did anyone, by raising hand, bring a specific question? Elijah, 32. Sorry, 22. Okay, let's do 32 by, basically, you raise your hand, you make a contribution to the problem, I'll pay you 2 points. Trying to illustrate the idea that AP questions are often solved not in a sequential manner, not by saying, hey, step 1 is this, step 2 is this. That's why it doesn't help to copy what I do. Every problem is different. So, not today, actually. We're good. Keep checking, though. So, raise your hand, offer a suggestion. We'll just kind of proceed from there. Because there's not really a sequential way of doing this. It's more like you just do things until you have enough clues on the board that you can see the correct answer. So,
well,
not today.
See that f prime of 3 is 2. So you know that the tangent slope when x is 3 has to be 2, right?
Well said. Hold on just 1 second. 2 for Hadley. Okay, anyone having problems recognizing exactly what Hadley just said? That symbol says on the graph of f, when x is equal to 3, the tangent slope will be 2. And there's nothing really to understand about that other than memorizing what the symbol means. When you need to say it again, just wait. Awesome. So we know now that the tangent slope on f, when x equals 3, has to be 2. Other ideas of things we can note, highlight, work on? Please, Brendan.
What would it mean if it just said f of 3 equals 2? If it didn't have f prime, would that mean that, like, is that showing just a point on f?
Perfect. So it would mean that at x equal 3, the y-coordinate on f is 2. So perfect. 2 for Brennan. Now, related to that, this has double meaning. There's 2 meanings to this. So what's the other meaning of this one? Let's go here.
We see that it's positive, and so if the derivative of f is positive, that means that it's increasing.
So what Maddie's saying is that we have a value of f prime at x equals 3 that is 2. And if the f prime value is positive, that means that the f function is increasing. Now, something to be really careful about. We would only know that at one point.
Yes.
So maybe helpful, but not usually. Usually we need to know over more space. So not a bad thought. Good connection. 2 points, but Just be a little cautious, it's only at one point. Hayden, please.
It says that the second derivative is less than 0, so it's negative, so that means that f is concave now.
That's really helpful, and also a very big clue on many problems. So let's see, the second derivative, now here's the difference between what Maddie said. This time it says the second derivative is always negative. So because the second derivative is always negative, the function itself will always be concave down. 2 points for sure. Don't forget here, so somebody else pick up 2 points and tell us again what this means. Somebody? Let's go, Cambry.
On the graph of f, when x equals 3, the tangent slope will be 2.
Perfect. On the graph of f, when x is equal to 3, the tangent slope will be 2. What's the second meaning of this that we haven't really mentioned? 2 points for Cambry. This has another meaning that you must have memorized. It's very related to what Brendan said. What's the second meaning of this statement? Please, Ellie.
On the graph f prime, the point is 2.
Perfect. So in the graph of f prime, there's a point at 3, 2. Same type of logic that Brendan was using. So make sure you know both meanings. 2 for Ellie. Pretty good? Okay, now I have just throw out a hint. If I'm working an AP problem, and they give me a table, they talk about a tangent slope, I immediately remember that I cannot find a tangent slope from a table. It's not possible. You don't have enough data. So what I often will do, even though I'm not sure if it will help, is I pay attention to secant slopes. When I have tables, secant slopes often are helpful. So I'm going to find all these secant slopes. Okay, wave at me if you need help understanding where all the numbers came from. So secant slope just means from point to point, what's output change versus input change. So from here to here, Rachel, how much did the output change?
2.5.
Good. And the input changed by?
1.
So that's what I'm calculating.
Okay.
Does that make sense?
Mm-hmm.
2 points. Anybody else? Awesome. I'll pay you if somebody can tell me why did I go to the trouble to put a 1 under all of them? Like, why? That seems like kind of a waste. I mean, dividing by 1 is not changing anything. Wes?
So that the x, like, whatever, well, sometimes it goes more than like 1.
Solid, solid. Nicely done. 2 points. Yeah, I wouldn't want you to forget. Secant slope is always output change divided by input change. And even though that input change is often 1, it isn't always. And I don't want you to slip into a trap. So, questions? Awesome. Okay, we discussed a concept last time, I believe. I look at my secant slopes, and I can immediately eliminate 2 of the possibilities. Raise your hand if you can see the 2 I'm going to eliminate. Hands. I'll pay everybody on this one. Which are the 2 I'm going to eliminate? There we go. Trey?
Would you eliminate G because it's still continuous? Or
Your thinking is right. The wording's not quite right, but no worries. So all of the functions are continuous. So that's not the right word, but you're on the right track.
yeah.
I look here and I say, hey, the secant's 2 between these 2 points, and then the secant slope is 2 again. That can't be true if you're working with a concave down graph. Concave down graph, this is my reminder right here. F prime means tangent slope, but it also reminds me that the secant slopes must also decrease. So from point to point, the secant slopes are not decreasing. This cannot be the right answer. 2 for Trey. How many knew it before I said it? 1. You wouldn't need me to say it again, just wave it. Awesome. So what else can be eliminated? Hands, everybody. What else can be eliminated? Everybody who knows. There we go. Tristan? For what reason?
Because it's, the secant slope is increasing.
Nice job. I was about to be offended. Do appreciate your nice correction there and break out the swear jar. Yeah, don't say yet. He corrected himself nicely. He said, oh yeah, the secant slope. So be specific. On the AP test, use of this word, or that's, yeah, they lose points. So how many knew we were going to eliminate E? 0.2 for Tristan. Questions? Awesome. We have a dilemma though. Here the secants are decreasing. Actually, all three cases the secants are decreasing. So I think I mentioned last time that with concave down, not only must the secants decrease, if you go secant tangent then secant, or tangent secant tangent, the pattern must also be decreasing. So raise your hand if you can see why they gave you this clue now. Okay, everybody on this one. So again, if the curve is concave down, you go from secant to tangent to secant, you must see a decreasing pattern. So what we have here is a curve that's concave down. Let's draw it on the main board. So we've got a concave down curve. We have some points on the curve. We know that the secant slope here, this secant slope, don't use that abbreviation on the AP test, that's just mine, is 2.5 over 1. We'll just say 2.5. This secant slope here is 1.5. As you go from secant to secant, you must have a decreasing pattern. We do. So why did they give us this? Hands up, come on, who can see why? Why did they give us this clue? Like, this is the key to figuring out whether it's A, B, or C. We don't need the clue to get these two gone, but we do need the clue to get these. Let's try Rachel.
Do you need that one to be in between the two of them?
Perfectly said. So the tangent, this is the point 3, comma 5. And at that point, the tangent slope, you should be able to see it visually. If you can't see it visually, wave at me so I can describe it differently until you see it. You should be comfortable that for a concave down curve, the green is the most positive slope. Then the red, then the pink. And they told us that the pink is 2. So this tangent slope is equal to 2. The only way to have a decreasing pattern as I go secant, tangent, secant is for this one. The others would have hit a little problem because the tangent in the middle is equal to 2. So it would not have had a decreasing pattern. How many knew it before Rachel said it? 0.2 for Rachel. Please, go ahead.
Will it always be secant, tangent, secant, or could they have given you f1 of 2 equals like 3 and then you figure it out from there?
They could have. I don't think I've ever seen a question that does that, but conceptually they certainly could. It doesn't have to be secant, tangent, secant. It could be tangent, secant, tangent. Same thing. So perfect. 2 points.
So I thought about it like the tangent slope is 2 secants that get closer to each other. And so I just found the middle number between each of the slopes. Is that right logic?
Oh, 2 points for that. The first part of the logic is perfect, Sarah. That the tangent really is like shorten this secant, shorten this secant. It doesn't always end up being right in the middle.
Oh.
So the right in the middle was just a coincidence. Like it literally could have been 2.4 for this one, and it still would be okay. So don't count on it being centered, but in between for sure.
Oh.
Yeah, in between for sure. Does that answer your question? Perfect. Brendan?
So, you know it was concave down, but is there anything that tells you that it's that side of the concave down? Like, why couldn't it have been the decreasing side of the concave down?
Awesome.
Like with just the two lines at the top.
No, really good question. Nothing in the clues here, 2 points. The only thing that indicated that it was the increasing side of the concave down were the y coordinates themselves, because they're going up.
But then on like E, it's still going up. Okay, I get it.
You okay?
Yeah, no, that makes sense.
No worries. Now, if it had been going the other way, like so,
You know, because then it would be getting bigger.
so now the slope, the secant slopes would have been negative, and they would have been getting increasingly negative. Well, that's still a decreasing pattern. Does that make sense?
Yeah.
So the logic doesn't change.
So you just had to look at the graph.
Correct.
Or the tables.
Does that make sense? Perfect. Anybody else? One other comment, eyes here. So I had to run to the office. Just pull it out for me, just sort of get distracted. You're fine. Hey, I had to run to the office, and one of my students in a B-Day class, she's like, I just don't understand any of the blue. If things aren't making sense, don't panic or anything. It's calculus. It's how it is. Okay. It just means you've got to carve out some time to be after school or before school, where you can just, in kind of a more relaxed setting, in a little smaller group, hopefully, just talk about it. Like literally, if you just talk about it enough, it'll click. Like you'll piece it together and you go, okay, now I see why I was confused. But calculus just isn't the kind of subject that always comes automatically the first time. So don't stress if it's confusing, just come talk about it. Any other questions here?
Can you
Please.
go over what you just said with Brendan?
Uh-huh.
One more time, sorry.
So he asked, how did I know that so I know the curve is concave down. But a concave down curve could be like this, or like this, or it could have been all the way, right? He asked how I knew, and I said, well, I really did, and I just kind of thought, well, wait a minute. Oh, and then I just looked and said, hey, the points are going up, so it had to be the rising half. If it had been this, you would have seen these points going down. The two secant slopes would have had to have been negative.
Yeah, okay.
But they still would have the decreasing pattern. So Danika's chart still doesn't fail me, which it never does. This would be a negative slope. This would be a more negative slope, hence a decreasing pattern. And then back to Sarah's comment, the tangent would still have to be in between. It doesn't have to be centered in between, but it's definitely in between.
Okay, that makes sense.
Is that your question? 2 points. Please, Rachel.
So all of that makes sense in like finding the concave and the slopes, but how do you know what you're looking for from reading the question? Just like you're
Gotcha.
talking about the intervals, and how do you know you're looking at a concave?
Outstanding. So she asked the 2 points for Rachel. As you're asking the question, I'm trying to think of the test and like, okay, how can I best advise you to like what to do on the test when you have that same feeling of like, okay, what am I supposed to do? Here's my advice, everybody. Really, really, really get used to the idea that in this class, you're going to solve a lot of problems by just try something else. It's not really guess and check. It's more like I read the problem and it says, okay, f is continuous, whatever, twice differentiable, not usually, I don't know, just keep reading. Here's a key clue. Tangent slope of f is 2 when x equals 3. I don't know why that helps, so I just keep reading. I did put a box around it. I did figure out that f is concave down. So answering your question, I still don't know what I'm doing.
Mm-hmm.
I'm just reading the problem and noting key things. Then I'm like, oh great, the question just ends all of a sudden. There's nothing else. Now, which table is the right table? So the next thing I did was just pure memorization.
Mm-hmm.
I remembered that when they give me tables, I can't find tangent slopes, but I can find secants.
Okay.
So I just kind of thought, hey, let's just see if it helps. Did I know it would help? No. So I find them. Once I have them written down, though, it triggers another memory, which is, oh, that's right, if a function's concave down, the secants have to decrease. So then I'm kind of moving a little bit. That got rid of these. That triggered another memory that, oh, that's right, the tangent has to fit in between.
Okay.
So it really was just kind of stumbling my way through it. Like I never was clear as to how to solve it. I just kind of came across the answer.
Okay.
It's like the worst explanation ever.
No, that makes sense.
Do you see what I mean a little bit? Hey, I would encourage everyone on any problem, don't hesitate to ask exactly what you asked. Like, how did I know where to go? And I'll try to keep feeding you like little things I've learned over the years that are like, yeah, if I hadn't kind of remembered that whole can't find tangents from tables, I'd probably be stuck just staring at it. So, no, good question. Brendan, please.
Okay, I know that there's lots of ways to solve problems, but like when I was following the same thing that you did when I was doing it, until you got the 3 graphs, so you knew it was one of the top 3. But then, how I found which one was 2 is I took like 6.5 minus 2.5, and then 4 minus 2, and then 7 minus, like, you know what I mean? I did that. So I'm asking. That's how I found out. And I mean, on A it was like 2. And on B it was like 2.25, and then on C it was like 1.75, you know, so I knew it was A. But I'm just asking, how did you pick which 3 of those graphs are without doing
Gotcha.
that?
2 points for Brendan. Everybody, hey. Okay, so what you did is good thinking, but I do want to caution against doing that.
Yeah, like what's the...
He found the secant from here to here, and it happened to be exactly the same as the tangent right in the middle.
Because it wouldn't like parallel.
Yeah, it would be parallel for sure in this case, but that's coincidence. So you don't want to count on that happening. It won't always happen.
Is it because it was in the middle?
It's because it was perfectly in the
But
middle.
if it wasn't, it wouldn't.
Correct. So don't count on that. What you can count on is secant followed by tangent followed by secant will decrease. It doesn't have to be all symmetric, like this is 2.5 to 2 to 1.5. No, this could be like 2.6, 1.9, 1.8. So no symmetry guaranteed. Does that make sense so far?
Yeah, so but it was because like on B it would be 2.5 and 2, so if the answer would be like in between 2.5 and 2, it wouldn't depend exactly.
No, keep talking though. Your questions are really good.
Like for A, you know 2 is in between 2.5 and 1.5, right?
Let me say back. That one's perfect. Yes, the 2 fits right in between. But the problem here, sorry to cut you off, is this. The curve must be concave down. Fair?
Yes.
So it's got to have this general shape. No choice. Option B says the first secant's 2.5. So I draw that. And I didn't mean to jump over your words.
No, you're good.
Brennan. So this slope, 2.5. Good?
And that's the same thing as what it is for A. Yeah.
Yes. And so then the tangent slope here, we know has to be 2. But this secant slope in part B was also calculated to be 2.
How do you know that the tangent's 2?
So we know the tangent is 2 because of this clue.
Okay.
So,
do you know it has to be 2?
yes.
But you don't know. Do you know if it is 2 for that graph?
It's 2.
It is.
Well, if the graph is the right one, it will be 2.
Okay, yeah. Yeah, so you're just plugging 2 in, like...
Checking it.
So is 2 what it actually would be on B if you graphed B?
Oh, gotcha. So let's look at B. I think you can answer this now. The things we know for certain about B is this secant's 2.5. This secant's 2, for certain. We like this to be 2 because that would cause it to be the right answer.
But it's not decreasing if it's 2.
Yeah, it's not possible. So this one can't be 2. It'd have to be something between these.
Okay, and then it would be something in between like 1.75 and 1.5
Yes.
on C, so that would be like 1.2.
Perfect. That's why those 2 tables don't fit the required clues.
So you figured out that way, not by doing the like slope.
Correct.
thing. Okay.
Yeah, the key was that I knew it had to be between.
Because if it was like 3.5, then it wouldn't have been right in between 2 and 4, so it wouldn't have.
Correct?
Yeah. Okay.
Yeah. Does that make sense? Anybody else? Memorize what he just said, though. That's the key. You go secant, tangent, secant. This has got to be in between. Please.
So why does the secant tangent and the secant have to be decreasing for a concave down? Like what is the?
That's literally the definition of a concave down curve.
So if it's not concave down.
Correct.
Okay.
Yep. It may have a section that's concave down, but it won't be purely concave down.
Okay.
That's just the definition. Perfect. Points? Awesome. Let's bring a different question. There is a hand. Let's go ahead. Outstanding discussion, by the way. That's how you really succeed on the tests in this class. Is you keep probing and probing, just like Brennan did, until he's like, okay, now I'm starting to see the real meaning of the concept, and if I can get that concept memorized, it'll come in handy on some question. So, please.
26.
26. Oh, I asked the right question. Hadley to the rescue. Well done. Here's why I say that. Everybody, like I'll leave it drawn. Look, 26 and 32 are testing the exact same concepts. So the AP test writers say to themselves, hey, these are identical problems. But they never like to give you problems that look the same, so they figure out a way to present the information differently, but in reality they are testing the exact same concepts. So I'll just let you ask questions for a minute and see if you can see why it's testing the same concepts. Like, look at what I did. It's all kind of written here. If you can see the connection, then you're well prepared for a new problem that's going to teach the same concepts as well. But you've got to see the connection. So people want to make comments about what I've done, I'll pay you, but I just want you to kind of discuss it as I help guide the discussion. So what do you see that looks like the same as what we did on the last one? Why we did it? Cass?
We found the secant slope.
We have a table, so like I said to Rachel, can't find tangents from a table, so I thought to find some secant slopes. So I did. The secant between these 2 points is 2. And this is back to Weston's comment, point for Weston, 2 for Cass. The change in x is not 1. That's exactly what I was warning you about. So I've got these 2 secant slopes. Now think of what Brennan talked about. What do you know about 2 secant slopes? Somebody answer this. What do you know about 2 secant slopes on a curve? Like, what did we just learn about 2 secant slopes and how they relate to tangent slopes? What's the big idea, Cass?
The tangent has to be in between.
Tangent's got to be in between. So they're asking us to find the tangent slope of f right here when x is equal to 1.2. Well, 1.2 is right in the middle of the red secant and the blue secant. I drew it here. The red secant is 2. My color coding is wrong. We can fix that maybe. So this is really blue here. So this tangent slope has got to fit in between. It's exactly the same idea. 2 for Cass. Follow-up question. Please.
So just because it says calculator allowed doesn't mean you need to use your calculator, right? Because like you didn't do it for 32.
Correct. I put calculator allowed just because in a moment of sympathy for all of you, I worried that perhaps someone might forget how to divide 0.2 by 0.1, and I just felt bad. So I'm like, well, if you forget, you can grab your calculator. But it doesn't mean anybody else. And in reality, on the actual calculator allowed section of the AP test, a good number of the questions absolutely do not even, the calculator doesn't help. Like, it doesn't matter how good you are, the calculator won't help at all. They just put them on the calculator allowed section. So, point for Brennan? Anybody else here? Now let's bring a different question. Please, let's go to the back. Lindsay.
Go over 27.
Okay, 27. Okay, key things. The word polynomial. So please memorize. When you see the word polynomial, you remember. Function is continuous, function is differentiable, and so are all the derivatives. So everything associated with a polynomial function is nice and easy to deal with. Okay, because all polynomials and all their derivatives are continuous and differentiable. You don't run into anything that's a problem. Please remember, a table only shows selected values. Which of the following statements must be true? It says f is increasing on the interval. The Danika's chart will not let you down. If you look here, I can't figure out whether f is increasing by studying f double prime. So what they're testing you on is, do you understand that? Do you understand that I cannot figure out if f is increasing if all I have is f double prime? So with just a few selected points of f double prime, there is no way to really figure out what f prime is, which is what I need to figure out if f is increasing. Because a table shows me 4 points when there are an infinite number of them. So that's a dead end. Follow-up questions on A, please.
So that is not the correct answer because we can't figure it out.
Yeah, there's just no way to figure it out. So it says right here, which of the following statements must be true? Based on this tiny bit of data, this could be true, but the data isn't enough to really declare that it must be true. Did that help?
Yeah.
2 points. Anybody else? I immediately cross off B and C. I'll pay everyone for this one. Raise your hand if you can tell me what's my logic. Like, I thought about A for a bit of time. I said, hey, I've got these points of f double prime. Well, yeah, knowing f double prime doesn't help me figure out whether f is increasing or decreasing. Only 4 points of f double prime. I don't really get much information about f prime. It's just not enough. They're just points. So as I said to Elijah, this could be true, but it certainly doesn't have to be true based on this data. But then I immediately just said B and C don't matter either. Why? Like, why can I get rid of those so quick after I've done that thorough analysis on A? Looking for help? Everybody who can read my mind on this one. What am I thinking? Here we go. Get a few people. What am I thinking? Weston's halfway there. Grant's, I can't tell if he's praying or asking. It's all good. It's asking for some help. It's right.
Well, for C, you don't know if it's a local maximum because you only have selected values, so there's no idea.
Decent logic. Point for that. It's not what I'm thinking, but it's good logic. No. What am I thinking? Why was I able to just cross off B and C like almost instantly? Like, what's my logic? Again, I'm trying to get you guys to think logically. Isaac?
You don't know, like, the velocity? You don't know if it's changing from increasing to decreasing, or if the velocity is going from positive to negative right there?
Good answer. I'm kind of in the same dilemma. Like, I couldn't figure out if A was true because I don't know f prime. All I have are 4 points of f double prime. Well, the same is true for B. Can't look here, and local max means f changes from increase to decrease. So my logic is, if I can't figure out if f is increasing, I certainly can't figure out if f is decreasing. And the local max means I've got to figure out increase to decrease. So losing the first one means the other two are no good either. Give yourself a point if you're with me on that one. Wesley, please.
I was just granted. It's just positive that.
Anybody else? Awesome. Okay. I've drawn the green plot. I've drawn the blue plot. Raise your hand if you can read my mind. What's my thinking when I draw, and this is f double prime. What's my thinking when I draw the blue plot? Just raise your hand if you can read my mind. Like, where does the blue plot come from? How did I draw it? Where does the blue plot come from? Give it another minute here. People are starting to dial in. Let's go Tessa.
The 3 points that you have in the table.
So I graphed the 3 points. And then I just do the kind of normal thing. I just kind of connect the dots. How many saw that point? I look at this and say, well, right here, okay, this is the point 1, 0, which means this black line is the x-axis. So I'm thinking, okay, my f double prime is changing from having positive y coordinates to having negative y coordinates. Right here, positive y coordinates to negative y coordinates. When that happens, the graph of f would have to change concavity. So f would have to have a point of inflection right here at x equal 1. That's the spot right here, x equal 1. So there's a hint on the board, but what's wrong with my logic? That's the wrong answer. So hands, what's wrong with my logic? Few people. Look at the green graph, look at the blue graph, so you can see why I declared that this was a very successful trap. The test writers are going to catch a whole bunch of people, and they're really cruel because they make this D and this E. So you read D and you're like, oh, that's the right answer. You circle it and you move on. And you get your test back and you're like, oh, what the? It's not the right answer. So what's my logic? Let's go see if somebody knew this. Let's go, Lindsay.
We only have selected values of f double prime, so we can't draw a inverse point.
Nice. Did I do my little weird thing last time where I draw all crazy? Yeah. The graph of f double prime could be the green. It has to hit this point. But right here, the green graph of f double prime does not change. The green graph of f double prime is positive, 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 0, positive. So the required change on f double prime from positive to negative doesn't occur at x equal 1 for the green graph. Wait, if you need me to say that again. So the f double prime has to go through those points. But beyond that, we don't know what f double prime does. So maybe f double prime comes down like this, has positive coordinate, positive, 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 0, then positive again. If that's true, this doesn't occur at x equal 1. If this doesn't occur at x equal 1, no point of inflection on f at that point, because the change in concavity would not have occurred. That makes sense? Now, I do have to cross the axis, because the graph has got to get to this point, and the graph is continuous because we're working with a polynomial. So this statement is true. Like somewhere between here and here, bad drawing, try again. Come on. Come back, you dumb thing. Hold on. So somewhere between here and here, yes, f double prime has got to cross the axis, causing an inflection point on f somewhere in there. So, please, Brent.
Okay, so I used to think that just when it hit 0 exactly, then you could like assume it was like where the inflection point is or where the critical point is, but it has to go all the way through. But I guess what I'm asking is, you know, the problems that like what is it in problem like number 12, where it like you mark off where it hits it, but it's like on this one it like barely doesn't. But like if it did hit 0, would you count it as a critical value, even though it, or would you count it as a critical value if it hit 0, but you wouldn't count it as an inflection point if it was a double prime graph?
You are stating that perfectly.
Does that make sense?
Mm-hmm.
Okay.
Yes, I need to give you a compliment.
I like.
No, seriously.
That doesn't make sense, but
Put down 2 points. Okay, everybody, come on, listen. If you can all get to the point where Brennan was right there in this class, you are on your way to amazing success in this class and many others. promise. Here's why. Like, you're just getting really comfortable with just kind of saying what you're thinking, and as you think, you kind of make little corrections. You go, oh, wait a minute, that's not right. Let's say this again. Like, it's like you're just fearless about whether you make a mistake or not. You don't care. You're just like, hey, just forge ahead, keep talking. Eventually, I'll get it all straightened out. If you'll all do that, you will be just fine in this class. You did have it a little bit mixed up in the beginning, but eventually you straightened it all out perfectly. To have a point of inflection, the f double prime has to change. So f double prime equaling 0 isn't enough. Has to be a change. Does that make sense? Critical point is different.
It touches it.
Right, because the definition of a critical point for f is where f prime is simply equal to 0. So a touch is good enough. Didn't have to change.
So on like 12, it looks like it just barely approaches 0 and it doesn't. Do you just like get to assume that it doesn't go to 0 unless it tells you?
So raise your hand, please, if this graph at this spot caused a little more anxiety than you would have liked because you just couldn't quite decide, like Brendan said, am I supposed to count that as a touch or am I not supposed to count it as a touch? Show me your hands, be honest. How many felt like disturbed by this? Okay, so I'll pay you in a moment, hands down. Okay, that's my fault, not yours. The AP test writers won't make a mistake like I did. They'll make it clear that you can tell. Or it will be a calculator allowed problem where you could zoom in and determine for yourself. So that's just my mistake. So if that caused anxiety, give yourself 5 points. Don't try to cause extra anxiety. Calculus is good enough. I don't need to add extras. So. But answering your question, this is f prime. So if this spot did touch 0, that would be a critical point of f.
Okay.
If this were f double prime, however, right here, f double prime would not be changing from negative to positive. F double prime would simply say negative, 0, negative, 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 negative. So that would not be a point of inflection on f.
So like if it was an f double prime and it did have like if it did have a dot at what is it at 1 at 3 and or whatever 3.5, I don't know.
You're good. So there's a dot at
So like if it
1
had a
and
dot,
about 2.5. About,
if it also had a dot at 6.
yes,
And then
very
it said
good.
what are the inflection points? Some people you would just count how many times it hit the 0, but then you'd be off one because it never actually went above,
Correct.
even though it hit.
Correct. Correct.
But if it doesn't even hit either, if it doesn't even hit in the first place, it isn't critical or.
Correct. Perfect. Say it back to you one more time. So if this is f prime, and the graph actually does have, the graph of f prime has values of 0, here, 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 and here. That would mean that f has 4 critical points, f. If this is f double prime, and the graph of f double prime has a 0 here, 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 and here, if this 0 doesn't cross, then this would not be an inflection point of f. These 3 would.
But it would be a critical point of f prime.
Yes, perfect.
Okay, because it's the same.
Yep, perfect. Here we go. Go, please, Rachel.
So when it's talking about the critical point, it talks about when the tangent slope is 0 too. I thought that the tangent slope could be 0 just when it flattens out. So every time, so is that not right?
So your thinking is halfway there. Just got to fill in just a little bit.
Okay.
It all depends on everybody. Hey, key to the test is this. Make sure you are totally comfortable with what am I looking at. Okay, so here I'm looking at f prime. And then be comfortable with what are they asking about. So I'll give you some examples. Let's play for points. This is a graph of f prime. Don't worry about the vertical asymptote. We'll just kind of start looking from here over. Okay? Raise your hand if you can tell me how many critical points, listen carefully to the question, this is how they trick you. This is f prime. How many critical points does f prime have from here to here? How many critical points does f prime have? Here's the definition. That's what you were saying. Any function has a critical point if that exact same function has a tangent slope that is 0 or undefined. So you're looking at f prime, I want to know how many critical points do you see on f prime? Hands, come on. Count them. How many critical points do you see on f prime? So Avery?
7.
So Avery says, from looking at f prime, the critical points of f prime occur where the tangent slope of f prime is 0 or undefined. She counts. 1, 2, 3, 4, 5, 6. We don't count the undefined one. So I get 6 critical points. How many counted 6? Show me. Point. That's on f prime. This is the whole reason you can't use this word. We've got to be really clear. What are we talking about? We're talking about f prime having critical points. Now here's the connection that Rachel was kind of searching for. F has critical points when f has a tangent slope of 0. But because f prime's y coordinates are the tangent slopes of f, I can find how many times f has a tangent slope of 0 by counting these spots. Those y coordinates being 0 mean on the graph of f, which I can't see, I would find tangent slopes of 0 in those spots. Is that your question? Mm-hmm. Perfect. Anybody else? Let's have a different question we'll look at.
Number 17.
17. Okay, this is another good example of Rachel's question. Point for Rachel. Okay, I can read this problem over and over again and I can never figure out what I'm supposed to do. I just can't. But if I slow down and just do a little bit at a time, eventually I'll get enough things on the board that I can figure it out. So you've got to go way slower than you're used to. Like, you're just accustomed to kind of read quick, recognize that you've done it before and do it. No, this class is all about real problem solving where you don't know what you're doing. So don't expect to. If the line tangent to a graph, stop right there. Okay, whenever I read the words line tangent to a graph, I draw the exact same picture over and over again. I've done it so much that somebody was very kind and they gave me a framed version of what I've drawn on the board hundreds of times throughout the year. Okay, Mr. Smith's favorite picture. So that's what I always draw. The artwork in my house is not very interesting, but you know, so my little kids, you know, always growing up, okay, draw your favorite picture again. They're just kidding. All over the fridge, this kind of stuff. Just kidding. Okay, so put a dot here. Okay, so line tangent to the graph. So here's the line tangent. Drawn badly, so you have to do it again. There we go. Question? It says the line is tangent at the point 1,7. Now I want everyone to try. If you're wrong, it's fine. I'll just pay if you try. It says the line tangent to the graph of f at the point 1,7 passes through the point -2, -2. So raise your hand if you can tell me, where should I draw the point -2, -2? Hands up. It's really a reading question. It's not a math question at all. It's just a reading. Can you read that sentence properly? Where do I draw the point? And this one, if your hand is raised, you get points for just trying. So right or wrong, okay. So Noah, what do you got?
Somewhere along the tangent.
Read perfectly. Read perfectly. This point is on the tangent. It states that from the reading. So I just look at where I've got this point and go, okay, -2, so it's got to be over here somewhere. So I draw over here. So if you had your hand raised, give yourself 2. If you got it right, give yourself 2 as well. I just wanted to see if you're trying. How many got it right? Just show me. Awesome. Question. Cool. Richard, if you know the meaning of this symbol right here. We tested you on this earlier today. Hands up, what's the meaning of that symbol? What's the meaning of f prime of 1? Anna Kate?
The tangent slope of 1.
Close. Just say it again. So the tangent slope of what?
Of the F graph.
So it's the tangent slope of the f graph. And the f graph has an infinite number of different tangents. So which tangent is this one?
It's on
Perfect. So this is the tangent slope of f when x equals 1. How do you do it? Point to for any questions. So that means this. I'm looking for this slope right here. That little teeny tangent slope. Okay, but it's really hard to calculate the slope of one tiny, 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 tiny line. So conveniently, I can extend it. And when I extend it, it becomes the red line. So finding f prime of 1 means find the slope of the short line. It also means find the slope of the red line. Raise your hand if you know how to find the slope of the red line. Drew?
You do the, well, what I did the difference between the y coordinate over the difference between the x coordinate.
Perfect. So I just say, hey, slope means change in output divided by change in input. So, how many knew it before Drew said it? 0.2 for Drew. Follow-up question? The follow-up today has been amazing, like super good. You good? Oh, Avery, please.
So I'm kind of confused, like, I understand how to find the slope and everything, but I'm kind of confused at how, like, we got to, oh, this means that we have to find the slope if we're trying to find f prime of 1. Like, I guess that's the tangent slope, but I'm just like,
So let's just try and keep filling it until it feels really good. Again, I really didn't know what I was doing when I started. I just do things and hope that I'm doing something that's helpful. So when it said line tangent to the graph, it's back to what I said to Rachel. Line tangent to the graph, I just memorized. That's my clue to draw this. So like before, when I see a table, I'm not sure what to do. I just do some secants and hope it helps. So you get that?
yeah.
Awesome.
I think the part that I'm kind of confused on is like y is at like x equals 1 and like how that works. Because if you're finding the slope, then how is it like when x equals 1? Because that's the overall slope of that segment instead of like at, I mean, I guess if it's the same, since it's just tangent.
See if this helps. The way we would find the slope right at that point is we would draw a secant to the right and a secant to the left. And those two secants would not have a slope of 3. But then I would bring the points closer like this until they become really, really short. Eventually the two secant slopes will be something like this. That will be this secant slope. The one above will be something like this. Does that make sense? So then I conclude that, hey, the slope right in the middle must be what's in the middle. It must be 3. Like there's just no option. So that's how we actually find a tangent slope, is using the secant. Seems to me your question is, well, why did we find the slope of the red?
Well, no, that makes sense. Because like you don't have the secant of like the upper secant. You're just finding the like the bottom half, right here.
Not really. We're really not finding these secants at all. What we're doing instead is we're saying, well, if we could do that, we'd find the answer to be 3. We would. We just can't. So what we do instead, let me get rid of this here. Too many things to back up. There we go. What we do instead is we say, oh, easier. I want the slope right at that point. That's that tiny, tiny, infinitesimally short line. But if you were to take that line and just make it longer, the red line has exactly the same slope as the little bright green one. But the red line slope is easy to find because they gave us 2 points on it.
Okay.
That's what we ended up doing.
Okay.
Let me say it a different way, but you're right. Hey, all eyes up, look up. See if you can click, like make this connection. Okay, see if this helps. Finding the slope of the red line, like y'all learned that like 8th grade, I think. Fair? Not? Yeah. Okay. Finding the slope of a line. It's nothing new, right? All that's new is what does this mean? The symbol f prime of 1 means follow the curve, get exactly to x equal 1, and find the slope right there. But now we know what tangent line means. We can say, oh, finding the slope of the green at that spot, no different than finding the slope of the red. And so we just use our 8th grade method to find the slope of the red because they're the same. Maybe that helps a little. So it seemed like that felt a little better. Point. Anybody else? Anybody else have a different question? Please.
18.
18. Tell me everything you can think of, Maddie. I think I know what maybe bothered you, but it's
Okay,
one
so
of the
I
things I think
figured it out, and I thought I figured it out the right way, and I got B because I know that. Sorry, let me read the problem.
You're good.
So it's asking when G is decreasing, and we know from Danika's chart that when f prime is negative, that means that the graph of f is decreasing. And so I saw that it's negative from -1 to 1. But then looking at the answers.
Got to the answer's A, right?
Yeah, and I was a little confused
You're
why
good.
the 0 was included.
You're good. The keyword is right here again.
Selected values, okay.
Okay, so let me draw a picture that hopefully will help.
Oh, okay.
We have a point at, let's see, x equals -2 and y equals 0. Okay? Then we have a point at x equal -1. Oops, wrong place, sorry. X equal -1. Y equal -3. With me?
Yeah.
We'll ignore the rest for a minute. Okay, this function is continuous. So it says g prime and g are both continuous. So that means we have to start here and we have to get to there. Stay with me, you're okay. Now we could do all kinds of crazy stuff, but we've got to get to there. With me? The other clue is right here. The function has only 2 zeros, meaning only 2 places where the value of the function is 0. So those 2 places are here and here, where g prime has a value of 0. With me?
Yeah.
Awesome. I therefore cannot do this. Let's get the whole room to answer this question. Why can't I draw g prime like this? What's the reason I'm not allowed to draw g prime like that? Hands up. Why can I not draw g prime like that? So Allison.
Isn't it because when, oh wait, isn't it because when D prime, no, D is,
No worries.
draw the chart.
You're okay. Point for that. No, hands up. Who knows? Why can I not do that? Rebecca?
So then there would be another 0 plus that.
Perfect. G prime can have only 2 zeros. One must occur here. The other must occur here. If I make this little bump, it doesn't work. So my only option, how many knew it? Show me hand. Point. My only option is to go down. So immediately after x equals -2, the y values of g prime are negative. So they start basically right there.
Okay.
Does that help?
That makes sense, yeah. Wouldn't it, like, not have the equal sign, like, greater than, less than, equals, like, wouldn't it?
Raise your hand if the answer had been this. You would have been much more comfortable that that had to be the right answer. Show me your hand. That's what you're asking, right?
Yeah.
Point. Okay, everybody listen. In the mathematical world, there's a bit of a controversy. There's lots of them. Here's one. Some people say that a function, some mathematicians say that a function is increasing all the way to the very top and including the top. So they write it like this, including, like, because if g prime is 0, we have a flat spot, right? Or decreasing, it doesn't really matter. But some mathematicians say, no, 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 don't include the very bottom. That's where the function isn't decreasing or increasing. It's just hit its bottom. So because they can't agree, if you're doing the written section of the AP test, either answer is correct. This answer or this answer. The AP test writers, in this case at least, chose to go with the equal sign. So they'll count either one. Did that help? Perfect. It worked. That was for bringing 1 minute.
If it didn't have it has exactly 2 zeros, then would you
Well done. Yeah, without that clue, actually we're having all kinds of problems without that clue, because even these points here where the g prime is negative doesn't necessarily mean g prime stayed negative.
Yeah,
it could have bounced back up. Yeah. Well done.